Today I'll be doing Don Dalton for the final project B. In Dalton's early life, Dalton was an English meteorologist and chemist. He was a pioneer in the development of the modern atomic theory. When he was born on September 6, 1766, into the Quaker family. He was the youngest out of three and has lived all the way to adulthood. At the age of 12, he was in grammar school. As his brother was also in school, he also taught in school. So when he bought a school, he asked Dalton at the age of 12 to be his assistant. At the age of 15, he helped his older brother run a Quaker school nearby Kendall. When Dalton was a teacher, he looked up for two important mentors. Their names are L.A.I. Robinson, which had some scientific taste in the Eagle field, and John Go, which was a mathematical and classical scholar Kendall. He learned rudiments of mathematics, Greek, and Latin, and Robinson and Go were amateur meteorologists, but Dalton gained the knowledge from them, and this made him get interested in meteorologists. From the men, Dalton had gained practical knowledge in the construction and the use of meteorological instruments to see the daily weather, and he wrote in the records. Dalton was very interested in the meteorological measurement for the rest of his life. This leads him to the first book that he says everything that he has observed from the meteorological topics, which is all weather. His first book was called Meteorological Observation and Essay. It was published in the same year he was going to his new college. He's going into this new college in Manchester. His early scientific career was in 1793. He went to college and taught mathematics and took with him his first book with recollections of meteorological topics, based on all his own ideas. This book has everything about meteorology topics based on his own observations together with his own friends John Go and Peter Crossway. The book Dalton has made wasn't that famous at first. No one really knew what meteorologist was, and no one really was interested. But it had the book only had his original ideas and made a transition of meteorology from the topic of folklore to a scientific pursuit. Dalton had various observations on meteorological phenomenon. He only looked at his views, no other popular opinions or other views. In some of the papers, Dalton had contained his independent statement of Charles' laws, saying, all elastic fluids expand the same quantity by heat. He also has clarified that the air is not a cast of chemical solvent. Dalton had claimed that the force of repulsion thought to cause pressure acting only between atoms of the same kind, and that atoms in that mixture were surely different in weight and difficulty. He believed that every single atom had their different weights in the air. As you can see on how you view this video, on the right side, you can see his cover of the book. He discovered that the atmosphere was a physical mixture and was around 80% nitrogen and 20% oxygen, instead of certain compounds of elements. He measured the air capacity, which was water vapor, and other partial pressure with the temperatures. Dalton also defined partial pressure, words for physical law, and every mixture gases let out the same pressure is the same gas was the only one that was present. One of Dalton's peers was a British scientist named John Frederick Daniell, hailed Dalton as father of meteorology. He hailed him as father of meteorology. His nickname, he hailed him as father of meteorology, since he is always interested in the meteorology field and also is interested in weather. Based on how in his book he has all the records of each day of the weather. After being at the college, Dalton was elected as a member of the Manchester Literary and Philosophical Society. The first thing he contributed to society is about colorblindness, which he called Daltonism. Daltonism is for people who are colorblind with the color of red and green type. The name colorblindness was from the chemist, of course, from the person named John Dalton. His atomic theory. With Dalton being interested in meteorology, it led him to the atomic theory and the law of partial pressure. Dalton's most recognized work in society is his work in chemistry, was the atomic theory. This led him to atomic theory based on his interest in meteorology. He didn't know where he has gotten the theory, since he doesn't have a recollection of the subject, which were incomplete. All he knows is that he was interested in meteorology, and this led him to the atomic theory. This gave him only his observations and his theory of thinking for the atomic theory and elements, and the weight. He based his theory of partial pressure on the idea that particles like atoms in a mixture of gases repel one another, but not like atoms appear to react differently toward each other. What Dalton has discovered shows why each gas in a mixture behaves independently, since they all have different elements. Even though Dalton's views were later to be a mistake, it still shows useful purpose in allowing himself to forget the idea. This is a good way to have mistakes, since there's many mistakes that can be corrected in the future that can show people not to go towards the mistake and make a new discovery. Dalton claimed that atoms are different elements, vary in size and mass, and surely this claim is the cardinal feature of his atomic theory. Dalton believed that each atom had its own kind of atom. His thought processes were different from other people's ideas. Some believed that there is many different particles that could destroy the accessibility of nature. Of course, Dalton didn't believe that the other people believed, since he had his own ideas in mind. He focused on trying to find masses of each different kinds of atoms, since he didn't really look up to other people or look up to other people's opinions, and only worked his own way. Dalton claimed that considering the number of atoms of each element present in different chemical compounds, even though Dalton had taught chemistry for a couple of years, he had never yet performed actual research in chemistry, since he only observed the atomic theory and made his own theory in the elements. In October 1803, he said that an inquiry into relative weight of the ultimate particles of body is a subject, as far as I know, entirely new. I have lately been prosecuting this inquiry with a remarkable success, which shows that he is only looking at the things from the surface and learning things, and this is making him getting deeper and deeper into what he can find. Experiments on his weight and structure of an atom. You can see on the right side, this is what his first book had of his atoms, of how he thought it looked and how they work. Dalton calculated atom weight from percent of the compound by using an arbitrary system to deciding the likely atom structure of each compound. For example, if there are two elements that can be combined, their combination will occur in a set sequence, which you can see in the bottom. Each one has different sets and different shapes and sizes. He had said about measuring the masses of many elements, as well as hydrogen, oxygen, carbon, and nitrogen. Based on based on the way they combine with fixed masses of one another. If the measurements were to be meaningful, the elements had to be combined in a fixed proportion. But Dalton took this for granted and disregarded between the French chemists. He didn't want to believe what other people wanted to tell him to do. He wanted to see what he can do on his own observations. Dalton's measurements were unworked, as they were made him formulate the law of multiple proportion. This is when two elements from more than one compound have the mass of one element that combines with fixed mass of other ratios of small whole numbers. This then can be taken the elements as A and B. The different combinations between naturally occur according to the mass ratio of A, B. The principle of Dalton's law can be demonstrated using a simple experiment that involved a glass bottle and a large bowl of water. When a bottle is under water, the water contains is displaced, and the bottle is empty, and inside the bottle is hydrogen gas. Dalton's law primarily applies to ideal gases rather than real gases, since his only observation. Due to elasticity and low particle volume of molecules in ideal gases, there are amounts of pressure that exert by the hydrogen that can be identified using the chart that lists the pressure of water vapor at different temperatures. This is all thanks to Dalton's discovery. As the Swedish chemist John Jacob Berzelius wrote to Dalton, the law of multiple proportion is a mystery without the atomic theory. Dalton had provided the basis of the theory, since he only scratched the surface of what atomic theory is. And in the future, more and more people will be interested in chemistry and learn more than what Dalton has ever learned. Dalton's theory examines that the combination of compounds, saying that the tiny particles like atoms in a compound were compound atoms. In 1810, Dalton had published his second book, A New System of Chemical Philosophy. In the end, Dalton has composed a table listing the atom weight of all the elements, based on his atomic theory with atomic weight in each element. On his later years, at around age 50, Dalton only performed little scientific work in different fields. Since he's getting older and has learned more, he wants to learn more with it, learning in different fields to help him know perfectly on the elements. His atomic theory eventually began to prove his worth, and it became famous in being known. Dalton was elected into the Royal Society of London and was rewarded with an honorary degree. This helped him get more famous and being known of what he did with the atomic theory, and how he went from being interested as a little boy from meteorology all the way to growing up and becoming famous, having the theories of atomic theory with the elements of weight. In 1833, the government granted him a pension, which was given again, but not during 1836. It was during 1834, which was offered from the Doctorate of Law by the Edinburgh University. He was known to have two of it from 1836 and 1834. He continued to teach people in universities in the study of chemistry and mathematics. He had kept his reputation as a devout Quaker. People did think in college when he was doing his lecture that he was a bit awkward, since he didn't really know how to speak normally. He was speaking awkwardly in front of people, and people believed that chemist people would speak in lectures awkwardly. Dalton had lived a respectful life with no problems, having the interest and fascination of science still in his mind. all the way till the end. He was never married, so he didn't really have any problems with relationships. In 1837, Dalton had a stroke. This made him have a hard time with his speech this made him have trouble with his speech for the next year. After he had that first stroke, he had another one, and this time he died from the stroke on July 26, 1844, at his home in Manchester, England. He died quietly. He was provided with a civic funeral and granted full honor. He had found a way to weight atoms, and this made chemistry known and studied more as the years go by. That's it. Bye.